All right, so today we're going to start moving toward the standard algorithm. So before we start working on that sheet, let's go over some things. So first, what is an algorithm? If you're working by yourself, pause the video, see if you can explain what an algorithm is. If you're working with somebody else, have a conversation. What do you think an algorithm is? All right, so these are the things that an algorithm is. Number one, it goes step by step. So it says this is the first thing you do, this is the second thing you do, this is the third thing you do, and it's all about computing and putting numbers together. Another thing an algorithm is that every time, pardon me, you do it and you do it correctly, you will always, always, always get the right answer. The other thing is no matter how big or small, whatever the problem is, an algorithm will work. Okay, so anytime that you have an algorithm, you use it correctly, no matter the problem, you'll get the right answer. And normally we've invented it. So I don't know at this point, I mean, maybe in the future AI will invent all algorithms. That might be. But for the most part, at this point that I know of, we do that. And we want to make things a little simpler. I don't like that they use this word easy. But it's simpler. We want to make things simpler for us to think about. We do want efficient, and we want things done quickly. We do like that as mathematicians. But again, I would change that word from easy to simple. All right, so the idea of a standard algorithm, and that's what we're looking at here. We're looking at a standard algorithm for multiplication. So that means that when we use that term standard, it's about coming from a certain part of the world. And because our curriculum is based in the United States, we are looking at the U.S. standard multiplication algorithm. And most of the time, at least in our country, in the United States, when we're dealing with addition, subtraction, and multiplication, we go from the right to the left. And we go from the ones, and then the tens, and then the hundreds. So let me show you what I'm talking about. Over here on the left-hand side, here, let me get my, oops, stop that thing. Over here, so we have invented algorithm for addition. So you may have seen this before when you were learning how to add. So this is taking apart the place value. So this is 46 plus 37, and we turn that into 40 plus 30, 6 plus 7, and then add these two to get 83. But then there's also the standard algorithm for addition, where we're starting in the ones column and then moving over. Okay, here again, this invented algorithm works. This standard one is much more efficient. So if you look at those calculations here compared to there, this one is simpler. Okay, it might not make as much sense because there's things that we do with place value, which is a little weird, but it does get us the right answer. Same answer as over here. Now, here is where we are. We have, the last lesson was talking about partial products. This is where we're going. We'll be there in a couple lessons, this idea of the standard algorithm. And again, like it said, starting with the ones, going to the tens and hundreds and so forth. And again, we're going to figure this out today. The first thing we're going to do, so our standard algorithm goes from the bottom to the top. It goes from right to left. And it starts with the ones. Okay, so it goes from bottom to top, right to left, and we start with whatever in the ones. So this is what we're going to do, and this is the process we're just going to do today. Okay, and again, we're going to move towards this soon. The very first thing you're going to do with a problem is estimate. Then you're going to fill in the area model, but look at that. We have to start in that bottom right corner. The reason we're doing that is to get used to starting with the ones, because that's where our algorithm starts. Our standard algorithm starts at the ones. So this is the first calculation when we're doing the standard algorithm is 4 times 6. Okay, and then we're going to list those products over here and then add them all up. This is going to help us understand where the numbers come from in the standard algorithm. And so we're going to do these practices and then go from there. So the very first problem in our book is this example, and I'm going to walk us through that one. So watch this so you know what to do. So the very first thing we're going to do is estimate. So the way I estimate and the way that we should estimate on some level, I like to round up or down. So this is going to be 40 times 20, which is 800. Now you could also say that, man, 36 isn't that much more. So, and 24 is pretty close. So this could be 600, right? So it's going to be somewhere in between 600. If I round them both down to 30 and 20, it's going to be in between 600 and 800, I would imagine. Now here, they've done it for us. We are supposed to start with A. So this is 4 times 6 is 24. Then we go 4 times 30 is 120. 20 times 6 is 120. And 20 times 30 is 600. We put the partial products over here. So 4 times 6, we've done that, 24. 4 times 30 is 120. 120 again. And 600. And then we add those together to get 864, which is, we were right around there with our estimate. 800 looks pretty good. So that's what you're supposed to do. For the rest of them, you start with A. Well, no, you first start with estimating. You start with A, go A, B, C, D, fill this out, get your total, and then we'll rock and roll from here. Got it? Good, great. Have fun. All right, I'm going to solve number 1 now. Practice working from bottom to top, right to left. So first we're going to estimate. I'm going to make this 30 times 30, which is 900. But it could also, maybe I'll go 30 times 20, which is 6. So it's going to be in between that 600 and 900 again. Again, we want to start with A. So 6 times 8, 6 times 8, 48. 6 times 20, 6 times 20, 120. 20 times 8, 160. 20 times 20, 400. We fill that in here. Oops, 120, 160, 400, 8. 4 plus 2 is 6, plus 6 is 12. 1, 2, 3, 7. 728, pretty close to 900. Again, the estimate is just to save us from making a horrible mistake. Because when we don't estimate and we use an algorithm, we're like, I got the right answer. And then we just go. So maybe you make this really big mistake. And you just say, 20 times 20 is 4,000. And then you add everything together and you're like, 4,028. I got the answer right. Well, if you've estimated and got 900, you're like, wait a second, that's nowhere close. I think I've done something wrong. All right. Number 2. Okay, so it says, practice again. This time list the partial products in the 3rd column. Remember to go in order. So we have to do the work over there. All right, so first estimate. Estimate 30 times 20. Give me 600. Again, starting with A, 8 times 9 is 72. Now 8 times 20 equals 160. Now we're at 10 times 9 equals 90. And 10 times 20, 200. 2 plus 0 is 2. 7 plus 6 is 13 plus 9 is 22. 1 plus 1 is 2 plus 2 is 4. 422. That's close enough to 600. I feel like I did okay. I may have done something wrong. And number 3. Practice again. This time use the frame to help draw the area model. Then do it. So first I'm rounding up to 40, up to 30, 1200. Up to 40, wait, maybe 30, so 900, somewhere in between 900 and 1200. All right, so we're going to make our rectangle. We're going to make our areas. Those areas are 7 by 5. B is 7 times 30. C is 20 times 5. And D is 20 times 30. So we have 35, 210, 100, and 600. 35, 210, 100, 600. 5 plus 0 is 5. 3 plus 1 is 4. 2 plus 1 is 3 plus 6 is 9. 945. And last but not least, Again, this helps us with this calculation here. This is 3 times 4 times 100, 1200, because 10 times 10 is 100. 4 times 5 times 100, 2000. 7 times 2 times 100, 1400. 5 times 5 times 100, 2500. 8 times 3 times 100, 2400. 6 times 7 times 100, 4200. And then tomorrow, what do we got tomorrow, or the next one? We're going to start thinking a little bit more about that standard algorithm. So we'll get there tomorrow, or the next session, depending on when you're doing this. Ciao.